Welcome to my projectbazaar.com. Now we discuss about the product a novel no reference PSNR estimation method with regards to deblogging filtering effect in H.264 by AVC bitstreams. Now we discuss the abstract for the process. At first, the peak signal to noise ratio, that is PSNR monitoring, is an important application for video quality assessment of video systems at the receiver sites where no reference PSNR estimation is essential. Most of the PSNR estimation method for H.264 by AVC bitstreams ignore or do not consider the effect of deblocking filter. Instead, they are focused on estimating the mean square error, that is MSE, due to quantization. However, the PSNR estimation affected the deblocking filter cannot be negligible for squares of large picture resolution. In this paper, we proposed a MSE estimation method on H.264 by AVC bitstreams by considering the deblocking filter effect so that more accurate PSNR estimation can be made. For this, the total MSE between the original and reconstructed frames is separated into two terms of PSNR estimation, one due to quantization error and the other due to the deblocking filtering effect in H.264 by AVC bitstreams. In the proposed PSNR estimation, the contribution of deblocking filter to the total MSE is quantified by the compensation factor of each encoded picture type between the original and the deblocked frames. Now we discuss the flow diagram for the process. At first, the video file is taken from the dataset. The input is in the form of the AVI or .mp4 format. After getting the video file from the dataset folder, the video is converted into the frames. The frames is nothing but the sequence of image which is extracted from the single video. After extracting the number of frames from the video, the frames are undergoing for the process of encryption. For the encryption, we use the two techniques. Major two techniques is the first one is the transformation and then the second one is the quantization. After applying the transformation and the quantization, the deblocking filter is used. After the deblocking filter is used for the frames, the MSE estimation is undertaken. The MSE estimation is nothing but the mean square error estimation for the each and every frame in the video. After extracting the MSE estimation, the decryption is undertaken. After the decryption, the frames which are to be encrypted is decrypted. The quality of the decrypted frames remains the same as to the frames of the input original frame. Then after the decryption part, the motion estimation is undertaken. Now we discuss the initial running procedure for the process. At first, select the main.m file and right click in that file, then select the third option, run. Now the movie player was opened. In that movie player, you can see the movie. Then the pre-processed is undertaken. In the pre-processing, you have converted the image into a grayscale and the resized frames are shown. The pre-processed frames are in the grayscale form. The transformation and quantization was done for each and every frame. In the movie player, you can click the play button and then the movie was played. The first frame is considered as an I frame and the other remaining frames are considered as an P frame. The second frame, the third frame, the fourth frame, the fifth frame, the sixth frame, the seventh frame, the eighth frame, and the remaining two frames that are the frame 9 and the frame 10 is the P frame. The transformation and quantization is done for the all frames. Then H.264 by AVC bitstream conversion is occurred. After that, the bitstream was shown as a different image. Then the deblocking filter is applied. After the deblocking filter, motion estimation calculation process was done. Then the graphs are estimated for the each and every process. The graph 5 indicates the existing PSNR and the proposed motion estimation values. The x-axis consists of frame index, the y-axis consists of RHS and LHS. Then the figure 6 represents the three things, that one is motion estimation for T, motion estimation for DF and the motion estimation for Q. The x-axis represents the I frame and the y-axis represents the motion estimated value. Now the figure 7 indicates the motion estimated T, motion estimated DF, motion estimation Q. The x-axis represents the P frame and the y-axis represents the motion estimated value. Now the figure 8 indicates the motion estimation T, motion estimation DF, motion estimation Q values. The x-axis represents the P frame and the y-axis represents the motion estimation value. These are plotted in the same graph. Then the output as shown as again shown as an movie player. You can click the button, movie player, click button. So the video was running. Thank you.